Let's do it.
Hello, 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 hello everyone. I'm pleased to welcome Broody or Yun uh, into this amazing second dojo workshops. I think like many of you, looking at how receptive you were in the chat on Telegram, that you're looking after dojo content. And I think like today, Yun has also like interesting approach and interesting stuff to show us about gaming and on-chain gaming, and that all new engine which is Dojo. So first, thank you everyone to come here, and I know like many known faces in the chat, so that's good to see. And Yun, the floor is yours.
All right. I guess we can get into it. So I guess should I just give a I'll do a quick self-introduction. Um, so my name is Yun. My online handle is Broody. I'm a software engineer here at Cartridge. I've been with Cartridge for about a year now. Actually, like 2 days ago was my 1 year anniversary, so it's been pretty exciting. Um, So I work mainly on full stack at Cartridge. Recently it's mostly on the back end, a lot of Rust and Cairo development. Let's see. And prior to Cartridge, I've worked at a big corporate firm for many years, also doing software. Um, yeah, that's sort of my background. So this talk or this workshop is mainly going to be on Dojo Engine, and I was just talking with Edward that I think Loaf also did a Dojo Engine talk a few hours ago. So there's going to be some overlapping material, but hopefully, for those who've seen the first video, hopefully this you can use it like as reinforcement learning or keep me honest with my materials. Um, but yeah, so I have a few slides. So should I just share my screen now? I guess. Okay. Okay, let me know if you can see my screen. Oh no, I don't want that. Okay, this is fine. Okay, so Dojo Engine, right? So this workshop is going to be about building on-chain games with Dojo Engine. So what is Dojo Engine? Just real quick, Dojo Engine is a library that allows you to build on-chain games very quickly, very easily. We sort of abstract all of the hard stuff away, dealing with like contracts, deploying contracts, upgrading contracts, doing migration and all that stuff. So you can like focus on the core logic of your game. As you can see, Dojo is sort of like it's a community-driven effort. And if you come to our Discord and look at our GitHub repository, you're going to see like the contributors are from across the StartNet ecosystem. A lot of them are doing like game-focused projects. But yeah, take a look at the GitHub and you'll see like these contributors are really high caliber. They're amazing, and there has been a lot of like organic growth around the framework. So it's really exciting to see that happening. Um, so for this workshop, we're really just going to focus in on actually just two of the three sort of tools that's under Dojo. You'll see a lot of these tools, their names are like Japanese sort of inspired tools, and that seems to be like a common theme across all of the StartNet projects, which is cool. But the first tool is called Katana, and this is it means sword, and it's our local devnet. So it supports Cairo 0 and Cairo 1 contracts, and everything is built in Rust, so it's quote unquote blazing fast. We built it specifically for Dojo, but I believe there are other teams out there that's actually using Katana to deploy. I think the Kakarot team is deploying like ZK EVM contracts on Katana with pretty good success. So it's amazing to see other teams like utilizing this for other purposes. And then the second tool we're going to take a look at today is called Sozo. And Sozo, I believe it means creation in Japanese. it's really our CLI tool that helps you to interact with your world, right? So it helps you like deploy your contracts, and more importantly, it helps you to like upgrade your contracts or update your contracts when you make a change. And we'll run through all of these commands that Sozo has to offer later on. The last tool is called Tori, and Tori is really it's right now still a work in progress. We're very close. There's some gaps, but essentially Tori means gate, right? It's our indexer, and what it does, it indexes different transactions and events that happens on the blockchain, and it will store those in a local SQLite database. So that's one half of it, and the other half is it will provide a GraphQL server or a GraphQL endpoint for your like front ends to consume, right? So the GraphQL endpoint will have things like it'll support like subscription and introspection and a bunch of queries. It'll support pretty complex queries for you to retrieve data from your world. Okay, so again, we'll cover like Katana and Sozo in this workshop, but Tori, we'll do maybe another time. But this is sort of Dojo in a nutshell. Let's see, I think, yeah. So ECS architecture. So Dojo uses the ECS pattern. ECS stands for Entity Component System. And it's a way to like structure your program so that it's your game, so that it's like modular and flexible. In fact, this pattern is used like in like traditional gaming industry pretty prevalently. I think recently Unity SDK actually has now support for like an ECS pattern or ECS architecture. So it's a natural fit, I feel like, for on-chain games. And in the workshop, we're going to talk about a game with their mechanics and how we like translate that into this ECS pattern. Okay. I think, yeah, I think that's all of the like high-level slides I have. I really want to spend less time on the slides and sort of we can get into the workshop, more hands-on stuff. So for this workshop, we're going to look at a game I created about like 2 days ago. It's called Enter the Dojo. For those who want to follow along as I run through this, you can go to this link right here. This is a repository for the game. And if you already seen Loaf's presentation, you probably already have your environment set up with Dojo up and Rust and whatnot. So it might be pretty quick for you to get up and running. But you can also just watch, and we'll run through it here live. Okay, so I created this game with intention of like, so we wanted to do sort of like one of those to-do games that people can run through when they learn a new language or a new framework, right? So this is very much similar to that type of project. It's very basic. Well, the mechanics of this game is going to be, it's a one-on-one combat game, right? So there's going to be players taking turns attacking each other, and they can select from a list of moves. We have punch, we have kick, and we have special, and those deal like varying degrees of damage to the opponent. And to make it a little bit like random, a little bit not too deterministic, we're gonna include like a random component in it, where if you unleash a kick or a special, there's a chance of that attack not landing, right? So add a little bit of uncertainty in there. And then each player will start with like 100 HP, right? And then there's going to be 3 specials. So this player can only use the special attack 3 times throughout the game, right? And then let's see, each move, yeah. And a game state is reached when either player's health reaches 0, right? So I think pretty simple like mechanics. And then so we'll see how we can like take this and translate it into a ECS pattern or ECS architecture. So if you can think about like, excuse me, if you can think about like what are your game objects? Well, you have like a player, right? and that can be represented as an entity. An entity is really a collection of components, right? So then that means that under the player, you have your health component, right, which keeps track of like the amount of health that remains, and a special component that keeps track of, how many like special moves that player has left, right? And since, we want to create like instances of this game so that other people, we can have any number of game instances. We want to be able to have like a game entity that keeps track of each game instance state, right? So the game entity would have just like one component, and that component would, have like the game state, which is like the player address, the current number of, or the current player's turn, because it is, one-on-one turn-based combat. We want to make sure like the players, alternate turns. And then the number of turns that has happened is probably like a nice stat to keep track of. And then obviously like the winner of this game, right? So we'll keep it simple. There's two entities and really just three components, right? And then the system really just describes the logic of your game. So this is where, you would, if you think about like what kind of actions can someone like perform in your game, well, they can create a game, right? So that's one system. And then they can join a game, that's another system. And then when you have two players in a game, then, they can attack each other. So that's the third system, right? So I think like that's pretty straightforward, I feel like. One of the things that I included here, and it's not part of the ECS, it's just events. I just want to highlight some of the events we'll be logging. And these events can only be emitted in your system. And we want to log events like when a game is created, or when a player joins, or when a player is attacked, and when a game is over, right? The reason why we want to do this is eventually Tori is going to be able to pick this up, the indexer. Is going to be able to pick this up, and then it will be able to serve it to your front end, so you can display things like, oh, someone created a game, so someone can join it, or you can display like the last 25 like moves that someone made in your game, right? And more importantly, you could have like a leaderboard, who has the most wins and who has the most losses and whatnot, right? So yeah, I think that's it for the slide. So we're going to jump into the demo. Let me know if there's any questions. I don't think I can see.
There are no.
We're good?
Yeah, we're good.
Okay,
Yeah,
cool.
No questions so far.
Okay, sweet. So yeah, so let's jump into the repository, right? So this is enter the dojo. What you're going to see is we have the source directory. Let's just first take a look at the components of the game. So we mentioned that there's going to be three components: the game component, the health component, and special component, right? So we'll take a look at game component. So the way that you define a game component using Dojo is with this derive attribute with component. And you specify that this is you specify this component as a struct, right? So the component sort of like contains a state, right? The state, and this defines like the schema of that component. So with the game entity, like we mentioned, it keeps track of the player addresses, player 1, player 2, next to move, number of moves, and winner, right? And by the way, if you're not familiar with like Cairo, there's great material online. I think the Cairo book is quite useful. I included the link in the slide, so you're welcome to take a look at that, and they'll make it more clear what these like felt 252s are. But yeah, so there's a helper function that's defined here with a game trait. It's called isPlaying, and really it's just a helper function to determine if this player is a part of this game. I think we mentioned that the game logic resides in system, but this is just really a helper function, so it's not changing any of the component states. So this is just nice to have, I guess. So that's the game component. And we can take a look at the player component. The player component is really simple. We mentioned the player component has two, or the player entity, sorry, the player entity has two components, health and special, right? So this keeps track of how much life the player has left and how many specials the player has left. Okay. So that's all the components. We'll take a look at the logic of the game, which is all under systems now. So I think we want to look at, let's look at the game systems. So we mentioned that there was going to be a create game system and a join game system, right? And the way that you define a system in Dojo is using the system attribute, and then the system name with the module. So it's kind of similar to, I guess, how you define like a contract in Cairo, except this is the system. All your systems has one entry point, and it's the execute function. So when your world contract like calls your system, it's gonna be executing this method, right? The world contract will also your world contract will also provide you with a context variable. So this contains like the caller information. You can there's a command like startnet get caller address or something. Oops. Oh no, sorry. I think. Okay, cool. Let me know if the font is too small. Where were we? So startnet has this like get caller address or something like that. And this normally, like in a normal contract, you get the caller your caller address, right? But here it's actually, I think, getting the world address. So if you do want a caller address, you just parse this context and use the caller count. Okay. When we're creating game, we want to give this game like a unique ID, right? So you see these commands, I guess macros. These are like Dojo APIs that's provided for you. So this particular command, UUID, it generates an ID that's unique to your world. And if you look at like the code in the Dojo repository, it's really simple command. All it does is there's a nonce that's initialized as 0, and it when you read it, it passes back the nonce and increments it by 1, right? So the first time when someone creates a game in your world, this game ID is going to be 0. Okay. And the next thing we're going to do is we're going to set the game entity, right? And so this command set entity takes 2 parameters. It takes a key, and then it takes a bunch of components. In this case, there's only one component, right? The way I think about the key is this is like some sort of like a composite key. So the way that the world address or the world contract stores your stores your state is, if you think about it, it's like a big hash table. And so the key represents your entity like key, and then the value represents all of the components that's associated with that entity. So we'll set the game object to game ID. Underneath the hood, it's going to do like a Poseidon hash with the system name, and so it generates like a single felt that's used as the key. Okay, so when we create like the game entity, we're going to initialize some variables. So since someone created the game, I think we would assume that they want to join the game, right? So we set the player 1's address to the player ID or the caller address, and then we initialize the rest of them to 0. So after this call, you can think that in your world now there is a game entity, right? But there's no player entity yet. So the next command, we're going to be setting the player entity, and then the key is going to be like a composite key of like the game ID and then the player ID, right? And at this location, the player entity consists of these two components, which is health and special, right? And you can take a look at the constants, what health max is, and where are the specials, right? And we'll talk about this in a bit. Okay, and the last step of create is we're going to fire off like an event, right? So the event fires off, and it's going to include the game ID and the player ID. So again, you would surface this probably on your front end and say, hey, a game was created. This is the game ID that's available for someone to join. Okay, so that's the create system. Let's take a look at the join system. Join system is pretty simple, I think. So we know what that does. The one thing that's different is with join, you want to give it like a game ID, right? It needs to know which game that you're trying to join. So in the execute method, we have both the context and then also a input parameter called game ID, right? So the first thing it's going to do is going to go into your storage and pull out the game entity at this ID, right? And this is another Dojo API. Keep in mind this API can fail if there is no entity or if there's no component at this key. If you have a game where you know that that component might not exist there, there's another API. It's called command try entity, right? And this will return like an option object, so it won't fail, or it won't assert. So if your game or your game component does exist, then we'll do some basic checks, right? We're gonna check that, hey, is player one the same player that's calling this join? If it is, then we're gonna assert because you can't join your own game, right? We're gonna check if player two is empty. If it's not, then that means that the game is full. And then if all those passes, then we're going to update the game entity using the same key, right? But we modify the player two address and then next to move. This I think can be modify a little, maybe use a transaction hash or something to determine which player acts first. But for now, we're just going to simplify things and say that next to move is going to be player one. Okay, so none moves and then winner is still 0. And then so we have a game entity, we have a player, and then we updated the game entity, and now we're going to create player two, right? So player two is going to have the same components as player one with the same starting attributes. Okay. So yeah, and then we'll fire off an event or emit an event for player that joined this game. So that's create and join system. Hopefully that makes sense. And then we'll take a look at the attack system. So attack is a little bit more involved, a little bit more complicated, but just relatively. It shouldn't be too bad. So when we said attack, the player would have a choice of 3 different actions, right? The player can either punch, kick, or use a special, and we'll represent them as an enum here. And then the same with the system. For this system, we're going to have 2 events. One event is the player attacked event. So, we will log for which game and who attacked who and for how much damage with what action. And then because when you're attacking, there might be a chance that, in this game, you deal a killing blow. So if that happens to be the case, then it's game over. So we'll fire we'll emit the game over event. And that just contains the game ID and the winner and loser, right? And then for this execute method, so there's going to be 2 parameters in this case now. We're going to need to pass in which game that you want to execute this against, and then also what is the action that you want to take, right? So we know what that is. We're going to read the game entity again. The one thing that is different than the game system here is that we're temporarily storing this as a variable. This is the key, right? your entity key. This type is called query. We're going to work on changing this name. We're going to make it something that's more suitable. I don't know, like keys or key, yeah, something along those lines. Just keep in mind that it's like the reason why this is called SK is it's called like storage key, but it's the key to your game, entity, right? Once you get that, and if that game does exist, we'll do some real quick checks. So if the game winner is not set yet, then we're fine. Otherwise, this game is already done. And then we validate that the next to move is in fact the current caller. Otherwise, it's not your turn, right? Okay, and then next we're gonna retrieve the current player, the current calling player, right? The reason why we do this is because the current calling player can trigger a special attack, and if you recall, the special attack has a limited number of moves, right? You can only execute 3 specials. What's like different here is that we're only like the player entity has a health and special component, right? But here we're only retrieving the special component. And the reason is because when a player attacks, it doesn't really affect their health. So we don't need to retrieve that component. But if you needed to retrieve that component, the syntax for that is oh, sorry. So the syntax for that is this, right?
Sorry, we have a question from
Yeah.
Contra Cousin asking, what does try entity do?
What entity?
Try entity, sending no in the chat.
Yeah, sure. So try entity basically it returns an option object. So this command here, entity, it will assert if there is no like component stored at this key, right? Your transaction is going to fail, right? But if you have a game where you know that there might not be a component that exists at this key, then you can use try entity. And what try entity will do is it'll search to see if that there is a component at that location. If there is none, it's going to return an option, right? And then you can check that option to say to like do like a condition on if it's some or none. If it's none, then you can handle that case. If there is something there, then you can handle for that case. Right? Hopefully that makes sense. But it's the same syntax. So if you're doing a try entity, it's going to be something like that, right? However, in our case, we know like we want to fail, right? If there is no entity at this key, because there's no like player that's been spawned, or there's no game that exists, right? Yeah, hopefully that makes sense. Okay, so let me revert some of these changes. So as we said, for our purposes, we're really only interested in special. And then so what we'll do next is we get the special component, and then we'll check to see if this action is coming in from like the method execute, right? We'll check to see if this action is a special, if the player is trying to trigger a special attack, right? If it is, we're going to go in and make sure that the player has enough special left, right? So if it's 0, then we're going to assert and say, yeah, you can't perform this attack. But if there is enough remaining, we're going to update the entity for this player for special and decrement the remaining specials, right? And then this next part is maybe kind of fun, but so now we'll calculate. So we'll now calculate the amount of damage that this attack can trigger, right? So right now we're just using the seed of we're using the transaction hash as the seed, right? But eventually you can use some sort of like BRF maybe to like make it purely random. So we'll take a look at this function call, calculate damage. It takes a seed and an action, right? The action is either punch, kick, or special. And then would determine like what is the damage, right? So it's determined by like the chance and the damage, the damage point. So if you look at constants, so if the player triggers a punch, that means that the attack will inflict 10 damage, and the chance of that happening is 100%. So anytime someone like triggers punch, you're guaranteed to land that. If they trigger a kick, the damage is twice the amount, but the chance of that landing is lower. There's only an 85% chance, right? And then if the player triggers like a special attack, that's 50 damage. That's half the maximum health. But there's only like a 25% likelihood of that like happening, right? However, if you hit like 2 of these back to back, then it's game over, right? So these are sort of the parameters that you can tune to make your game like balance, I guess, and maybe fun. But yeah, so that's calculate damage, and calculate damage returns a U8. So that's the damage that was inflicted. It could be either punch, kick, or special, or it could be 0, right? Where is calculate damage? Okay. So return that value, and then now we need to get the opposing player's ID, right? So that's stored in the game state, or sorry, the game component, and then once we get the opponent ID, we can query for the opponent component, the health component of the opponent. Sorry, we don't care about the opponent's special component because that special doesn't change, right? Only the health gets affected. So we just pull the health, and then we calculate. We see if this is a killing blow. So it's a killing blow if the damage exceeds the current health of that opponent of your opponent, right? And then we make the damage equal to the current health so that we don't have an overflow when we're updating the health. Right, and then killing blow. Oh, go ahead.
Sorry. So question is asking as well, are the attacks like punch, key already implemented directly?
Are they implemented directly? So they're just numbers, right? The attack does I guess I don't quite understand the question, but they're just numbers that takes away from the health bar. Like there's not a distinct system for punch, kick, or special. Like once this attack system is called, it's gonna read what is your opponent's health at the current level, and it's gonna determine what the damage is, and then it subtracts the damage from your health, from the opponent's health, and that becomes the new health of your opponent. Sorry, I guess, yeah, I don't know if that answered the question.
Yeah, I think it does. I mean, to me it does.
Okay, cool. So where was I? Yeah, so killing blow, right? So yeah, so whether or not this was a killing blow, and then we update the health of your opponent. So same thing, set entity, the key of your opponent, and then the health, and then we set the state, right? So I think this is pretty straightforward. Everything stays the same. Next to move, we now, if the opponent is still alive, then next to move is your opponent, and then the number of moves that have happened, and then a winner, right, if it was a killing blow. So yeah, so the rest is straightforward. These are just events that we fire off. We fire off a game over event if in fact someone died. Okay. Okay, so now we'll get into how to actually deploy this on Katana, how to execute some moves. So for that, we have this. Okay, so how the terminal is laid out. So there's no UI for this, unfortunately. Everything is going to be in terminals. So what we're gonna do is we're gonna simulate like the two players. Player one is gonna be here on the top left, and player two is here on top right. On the bottom is gonna be our Katana instance. So this is gonna be our local DevNet, right? So we fire off Katana first, and we're gonna give it a C so that all the pre-funded accounts are initialized to the same address every time. And what we're going to do is we're going to just use the first two addresses. So the first address represents your player one, and then the second address represents player two. Okay. And how we set this to these different terminals. So if you look at the directory of enter the dojo, there's a scarb.toml. The credentials of player one are all stored under the dojo.environment here. So account address and private key. It also specifies world address, but I think we need to like improve this a little bit. When we're first like doing migrate, there is no world address yet. So let's comment this out first for now. Okay. Okay, so Katana is up and running. So we can go ahead and build our game. Hopefully it builds. Okay, that built, and you can see it's in the target dev directory. So Sozo build will go in and compile all of your contracts, and you can see that the contracts are like your game component, your health component, and special, and I think there's like vote. But anyways, yeah, so all of your contracts are in your TAC. All of your contracts are here. You see quite a few like additional contracts, and these are like for access control management. And we won't go through that in this workshop, but that's something that's pretty important, and you can take a look at later on. Okay. Okay, so we've compiled our contracts, and then to deploy to Katana, it's one command, super simple, Sozo migrate. And you can see a lot of things happening. What it's doing is just declaring the contracts, and then there's only actually two contracts that gets deployed. The rest of the contracts are all only declared, right? So the contracts that are deployed are your executor and your world, and this is a contract that you're interested in. So the world contains like the entire state of your game, right? And then it will make like library calls to your system contracts, and then your component contracts has like the schema of the components, right? So now you see, we've deployed our contracts to Katana, and you can start using the Sozo command to look at the schema that's on chain. So there is something called Sozo component schema, right? If we want to take a look at, like, say for example, the game component. Oh, sorry. So we have to uncomment this. So this is the world address. We just want to make sure that this world address here is the same world address that was deployed on chain. Right. So now we can do Sozo component schema, and this returns like the on-chain schema, right? When you made this call, there was some RPC calls down here, right? Startnet call, and returned like the schema of this component, right? And this looks correct. We can also look at health and special. Okay, I think I'm short on time here. So yeah, so this is all the schema, and then what you can do is we have two systems, right? So we can execute create. This creates the game, right? And it was successful. And you might be wondering, well, how do I like inspect that the game entity now exists? So it's Sozo component, and then we're going to read the entity, and then the component name. Now, here's a little bit tricky because we remember when we created the game entity, right? The key is the game ID, right? And the first game that gets created in your world the UUID function returns 0, right? So the key is effectively 0, right? When you do that, it returns a bunch of, you know, numbers. So you can do this this again. So you can see that when we created the game, the field that was populated was player 1. Okay. Oh, okay. Okay, perfect. All right, so if you're willing to stay past the 45 minutes, yeah, that'd be great. Um, okay, so let's see. So we've created the game, right? So the create function created the game entity, and it also created the player entity. So now we have 2 like entities in our world storage. Okay, so right, so we've created that. So now we can join the game. So player 2 can join the game, but we can test that. What if player 1 tries to join their own game, right? So how do you do that? Sozo execute. This is, yeah, we did execute, and then join. And how you pass in the param. Remember, if you look at join, when you look at join, one of the parameters that you pass in is the game ID, right? So we pass it in as like a call data, and to pass in a call data, it's -c, right? And then the game ID here is 0. So we try to do that and return to failure, right? Why did it fail? Well, if you parse through this, you can see that in fact, yeah, you cannot join your own game, right? What if we tried to join a game that doesn't exist, say like at 1 or something, right? That also fails. And this is game not found. Now, this isn't an error message that I define in my game. So why is it failing there? Why does it know that, it's game not found? If you go back to join, it's failing at this command, this entity command. Remember, we were talking about like entity and try entity. So this one will fail if there is no like entity at that key, right? But if you use try entity, like we talked about, you'll get an option back. You can handle for some and none. Okay, so we can't join our own game. We can't join a game that doesn't exist. So with player 2, we will try join here. Oh, sorry, misspell. Cool. So player 2 was able to join successfully, and you saw that a block was mined, right? So now in our game world, there's 1 game, 2 players. And to check that, well, we can check the game, the game component again, right? And let's dump the schema too, so we know what we're looking at. So player 1, right? Player 2, and then next to move is player 1. So all of that checks out. Now we can start attacking each other. Okay, so next move is player 1. So I'm going to Sozo execute attack. And then the call data here is, I think I need to remind myself. Okay, so yeah. The call data is the game ID, and then the attack that you want to make, right? So what is the attack we want to make? Well, perhaps player 1 is feeling kind of lucky, so we're going to go directly for the special. So the special is 2. Yeah. Okay, so player 1 attacks and something happens. So this is a kind of anticlimactic. Once you have like the front end, it'd be much more flashier. But to check that things happen, we can look at the health of player 2, right? So we can inspect like the on-chain, like the storage of player 2's health. To do that, we need player 2's address, and we can do component entity health, right? And then we pass it the key, right? Now remember, for the player entity, the key is actually a combination of the game ID and the player address, right? So the key is effectively 0, comma, the player address. And now we can see it's 64. So hex 64 is 100. So in fact, you know, they didn't land the special, unfortunately. Okay, so player two, now it's player two's turn to attack. So player two attacks, same thing. It's going to be game ID 0, and then attack. Player two is going to be conservative and just throw a punch. And then we'll check the health of zero. Right. So this is the current state of player one's health. There's a really nice tool called StartNet Pro that I like to use. So, and there's some nice functions in there to convert like this to, yeah. So that gives like 90, right? That makes sense because punches are always guaranteed to inflict damage. So, you know, this can take quite some time, but we're just gonna go through, we're just gonna keep attacking each other. So player two is gonna gamble a little and throw another attack. Player one might do a kick, right? We'll just continue with this. Oh, right. So remember, if player one keeps throwing specials, there's only 3 specials. So this transaction failed because there's no specials left, right? So if so player one has to like do a kick or something. Sorry.
Someone asking, everyone can access the entities, or
Anyone can access. So anyone can access. So I wonder if they're talking about like access control. That's I think a bigger topic. So we can set up with routes such that only specific systems can access specific components, which are members of an entity. And that's how you set up like, you know, access control and permissioning. That's like a bigger problem. In fact, I'm not too familiar actually with like how that all works yet. But it's there. I would direct you to our Discord for like more clarity. But in our game, in this game, if you're asking if anyone can call these, right? Because your player ID is associated with your, you know, contract or your account address, right? Only and your player, like it's stored based off of your, you know, player ID. You know, only if you have like this account address can you call these systems. Yeah. Yeah, I would encourage you to explore more on the permission side. That's someone implemented that from forget which project, but it's pretty deep.
yeah. So basically, it's possible to hide some information to everyone, for example.
Oh, hiding information. Yeah, unfortunately, right now I don't think you can hide information on like StarkNet. I believe that should be enabled eventually when we have like L3s, where we can have like privacy. But in like the current models, yeah, I don't think you have like private information. So all of this is on chain. Yeah.
Thank you.
Okay, so we'll keep attacking each other. I just want to get to the end of this game. So I think these guys are okay. Finally, all right. So yeah, we kept kicking each other, and we finally got to the end of the game. Game over, right? So let's see what happened. We'll take a look at the game component and see what the current state is. Let's get the schema as well, so we know what we're looking at. Okay, so the winner is the last member, and the winner looks like is player 2, right? And then the number of turns, I should know this, but the number of turns taken was 14. So we went back and forth 14 times, and yeah, player 2 won. If you want to see like by how much of a margin player 2 won by, so we can look at the health of player 2. We'll just look at the health component. You can see it's 14. What is 14? 20. Okay, so So player one's health should now be like 0, right? Which it is. Yeah, and that's the end of the game. Let's see what else. Yeah, player two can also create a game. So if you do so execute like create. Now, once player two creates, now remember we're using the UUID call, right? So that increments your game ID by 1. So now everything should be like keyed at 1, right? And then so forth and so forth, right? So I'm trying to think if there's anything else that we should cover, but I think that's it. I think yeah, if if you guys have any other questions, yeah, feel free to drop into Discord, the Telegram. The group is like super active on Discord, so and Telegram. So you know, you'll get your answers or questions answered. But yeah.
Thank you. I think that yeah, there was no real overlap with
Oh,
Loaf of this
okay.
morning. So
That's,
like of course like some, but I think
yeah,
you covered different things, so it helped. I guess like lots of people. I know like maybe Baltazar is building something related to Dojo. I saw as well
very cool.
reviewing as well what participant building so far, building, and so they're already starting building on Dojo. So that's nice.
Awesome. That's great to hear. Yeah, excited to see what you guys have in store, or you guys are working on. So yeah.
Yeah, man. Like Country Cousin asking like I wish there was like a UI to visualize this game. Like you can build it.
Oh, yeah, it's actually not online. It's yeah, you're gonna have to build it and play it locally. I think eventually this could be like one of those games that you know we put as an example, and there's a front end, and people can you know visit it online. But for now, I can share you the slides that I have with the URLs, so you can access it.
Yeah, nice. Yeah, feel free as well to share with me, and I will include all the presentation and whatever the link shared during the workshops in the description on YouTube. As well as you mentioned, feel free as well to join the Discord of Dojo, the Discord for Realms, the Discord of Cartridge. There are lots of things happening there, and also not only you or Terence or other team member, but also the community is really involved into Dojo. So many members of your community can help you building and resolving your issues while hacking. So thank you. Is there any more question in the chat? Yeah, no question, but already people sharing stuff in the chat, so that's cool. Okay, thanks a lot for this workshop, Broody or Yoon. I will leave you contact as well in the description, as I said, and so you can easily interact and ask questions. So I will leave you to say the last words of these workshops, and we're going to wrap up.
Yeah, no, I mean, happy to have done that. Yeah, like I said, I'm really looking forward to the things that you guys are building. And any questions, feel free to reach out. But yeah, have a great hackathon.
Thank you. Goodbye, everyone.
All right.
Bye bye.